memorize all of those. Today, you're going to want your unit circle sheet out while you're taking notes, and you're going to want to look at the sum and difference formulas here. So keep that next to you while you're taking your notes so you have it to refer to. We are going to start notes on 5.4 day 1. Okay? So what I want you to start with is looking at these 3 things here and deciding, are any of them equal? Or are maybe 2 of them equal and 1 not? Or are none of them equal? So what you could do is you could plug those in your calculators and you could see if any of them are equal. You will find that these 2 statements are equal to one another, but that this statement right here is not equal to either of these 2. What happens when people who think that this works, it's because they think that you can distribute sine through, so they think you can do sine of 20 plus sine of 60. And distributive property does not work because you are not multiplying. So we are not taking sine times 20 degrees plus 60 degrees. Therefore, the distributive property does not work. So please remember, do not distribute trig functions. It's just not a correct thing to do. So what we want to learn is how to find something like sine of 80 degrees that's not on the unit circle sheet and give an exact answer. Exact means no decimals, so that would imply we're not going to just type this in our calculator and get a decimal. We want exact answers. So what we're going to do is break it up, and we're going to hopefully break it up into angles that are on your unit circle sheet. Let me give you a better example. One second here. I'm going to move this over a little bit so I can get to this. Okay. All right, so this page right here. These are our sum and difference formulas. These are on your unit circle sheet, so I want you to get familiar with them. We might be adding 2 numbers together or subtracting 2 numbers. And you have different formulas whether you're adding or subtracting. One of the angles will be designated as U, the other angle would be designated as V, and then you're just going to follow the formulas. Same thing with cosine. One thing to note is that even if you're adding angles, there's going to be a minus sign in the formula here. If you're subtracting angles, there'll be a plus sign, so that's a little counterintuitive. And then the tangent formulas look a little crazy, so just kind of expect that. All right, so here's the process. Let's say this is our problem right here, sine 75 degrees. Sine of 75 degrees is not on the unit circle, and we do not want you to just type this in your calculator and get a decimal because the directions want an exact value. So exact means no decimals. Okay, so we need to find a clever way to figure this out. We can break up the 75-degree angle into 2 angles that either add to 75 or subtract to 75. And we want them to be on the unit circle. That's step number 1. Break up the given angle into 2 angles that are on the unit circle. And they can either add to 75 or subtract to 75. So I'm going to do 30 degrees plus 45 degrees. All right, so I'm going to designate the 30-degree angle to be the U and the 45-degree angle to be the V. According to my formula of sine of U plus V, I'm supposed to do sine of U, which in this case would be sine of 30 degrees, times cosine of V, so cosine of 45 degrees, plus cosine of U, cosine 30 degrees times sine of v. So sine of 45 degrees. Now I can go to my unit circle and look up those values. So looking at the unit circle, sine at 30 degrees is 1/2. Cosine at 45 degrees is radical 2/2. And we're multiplying those together, keep that in mind. And then we're going to add, and then go to 30 degrees, look up cosine, it's radical 3/2. Sine at 45 degrees is radical 2/2, and remember we're multiplying them. And then just remember your order of operations, we need to multiply first before we add. And when we multiply straight across the top and get square root of 2, multiply straight across the bottom, we get a 4. Over here, multiplying straight across the top, because we're multiplying, we can combine the 3 and the 2 underneath a square root. So I can say it's the square root of 6. And again, on the bottom, 2 times 2 is 4. So multiplying, you are allowed to combine those square roots. But now that we're adding, we can only add like terms. And these are not like terms. So I have to just kind of keep them separated. Square root of 2 plus square root of 6 all over my common denominator of 4. And that's as good as it's going to get. So we took an angle that is not on the unit circle. We found two angles that are, used our unit circle, got our exact value. Okay, let's try another one. Okay, we're going to find the exact value of tangent of 165 degrees. So you pick two angles that are on the unit circle sheet that either add up to or subtract to 165. And there's multiple ways to do these problems. You can pick lots of different angles that either add or subtract to 165. I'm going to choose 135 degrees plus 30 degrees. So I'm making U 135 and V 30. Now, because we're adding, those could be flip-flopped. The U could be 30, the V could be 135. It's all going to work out to be the same in the end, so it's not that big of a deal. So look at your formula sheet for the formula for tangent U plus V. It says we're supposed to do tangent of U, so tangent of 135 degrees, plus tangent of V, so tangent of 30 degrees, divided by 1 minus tangent of U, so tangent 135 degrees, times tangent of V, tangent of 30 degrees. All right, so now we're going to go to our unit circle. And I'm going to color code this just because it could easily get a little bit messy. So on the top, tangent of 135 degrees is -1. And tangent of 30 degrees is square root of 3/3. That is all of this stuff on the top of my fraction. Okay, on the bottom of the fraction, 1 minus tangent of 135, which is -1, times tangent of 30, which is square root of 3/3. So all of this stuff right here is in black. Okay. Now on the top, the stuff in red, I cannot add those until I have a common denominator. Right now, I could write that as -1/1, and I could multiply by 3 on top and bottom. Okay, so my common denominator is 3, and then on top I would have 3 plus square root of 3. Okay, and then all of that divided by, and then the stuff in black, -1 times square root of 3/3 would be a negative square root of 3/3, and then I'd have 1 minus that. So really I could do 1 plus. Minus a negative turns into a plus. And I would need a common denominator for these as well. Okay, I'm running out of room, so I'm going to go this direction now. So the stuff in red is 3 plus square root of 3 over 3. The stuff in black would be 3 plus square root of 3 over 3. Oops, I made a little mistake up here. I can barely see my -1. That should have been a -3, and this should be a -3, because up here it was 3 times -1. Okay, so now this looks like a mess because we've got fractions within fractions. So let's multiply by the reciprocal. So I'm going to take all the red stuff, -3 plus square root of 3 over 3, and we're going to multiply by the reciprocal of the stuff in the denominator, which would be 3 over 3 plus square root of 3. And then what you'll notice is these 3's cancel. So I will be left with -3 plus square root of 3 over 3 plus square root of 3. Now, you can stop there. I know that there's a radical in the denominator, and typically we don't like that. If it was just a square root of 3 in the denominator, we would want to rationalize that. But we've got a 3 plus square root of 3, and AP Calculus doesn't even make you simplify this, so we're not going to make you simplify it either. The back of the book, however, will. They will rationalize the denominator, so their answer in the back will be different than this. But we are okay if you stop here, okay? Okay, so again, we split up the 165-degree angle into two angles that are on the unit circle, followed the formula. We had to find some common denominators, so we had to do some algebra work. We multiplied by the reciprocal, which canceled those 3's, and then that's where we ended up. So it's going to be kind of a lot of algebra work once you get through following the formula. Okay, this one, our angle is in radians. Now, trying to find two angles that either add to 5 pi over 12 or subtract to 5 pi over 12 in radians might be trickier than you'd want to do. So you can totally just change that into degrees. That's what I would do. It's just easier to think of two angles in degrees that add or subtract. So if we're going to change 5 pi over 12 into degrees, we're going to multiply by 180 over pi. The pi's will cancel. 5 times 180 divided by 12, you're going to get 75 degrees. So I would just treat this problem as cosine 75 degrees. Find two angles that add up to 75 or subtract to give you 75, because 75 is not on the unit circle. So I'm going to do 30 plus 45. So for me, 30 will be the u, 45 will be the v. We have to follow the formula for cosine u plus v, which says to do cosine u, cosine v, minus sine u, sine v. Now that we've got the formula written out, we're going to actually go to our unit circle. So go to 30 degrees. The value of cosine is square root of 3 over 2. At 45 degrees, the value of cosine is square root of 2 over 2. And remember, we're multiplying. Minus sine of 30 degrees is 1/2. Sine of 45 degrees is square root of 2 over 2. And we're multiplying those. So multiply before we subtract. Multiplying straight across the top, we get square root of 6. Straight across the bottom, we get a 4. Over here, multiplying straight across the top, we get a square root of 2. Straight across the bottom, we get a 4. These do not combine. They're not like terms, so we're just going to rewrite it all over our common denominator of 4. That's it. Okay. Next up, okay, sometimes we need to use the formulas going backwards. With these problems, 110 and 80, those are not on the unit circle sheet, so I can't just look up what sine and cosine are. But I might recognize sine times cosine plus cosine times sine. And if I think about that as u's and v's, I would have sine u cosine v plus cosine u sine v. And I want you to recognize, oh, that's the formula for sine of u plus v. And you can go backwards with these formulas. So in this case, the u is 110 degrees and the v is 80 degrees. And I can add those together and get sine of 190 degrees. Now, 190 degrees is not on the unit circle sheet, so that's as simple as I can make it look. For part B, I've got tangent of u plus tangent of v divided by 1 minus tangent of u tangent of v. So if I look on the formula sheet, that would be the tangent of u plus v formula. So in this case, it would be tangent of 140 degrees plus 100 degrees. And we can add those together, and we will get tangent of 240 degrees. And that's as good as that one's going to get. The directions are probably going to say something like simplify. So that's as simplified as we can go. Down here, if I assign those u's and v's, I have cosine u cosine v minus sine u sine v. That is the formula for cosine of u plus v. Excuse me. So u is 50 degrees and v is 85 degrees. And when I add those up, I will have cosine of 135 degrees. But this is on the unit circle. So we can take it one step further and actually figure out what cosine at 135 degrees is. And it is negative square root of 2 over 2. So this one simplified a little bit farther because it actually was on the unit circle. Okay, last example. Okay, here we need to be a little bit more cautious. We're going to be given some clues about angle U and angle V, and we need to really pay attention to those clues. So here it says angle U is in quadrant 2. Draw a picture of a triangle in quadrant 2, and this is angle U, so label it a U. We're told sine of U is 4/5. Sine is opposite over hypotenuse. So I know that this opposite side is a 4 and the hypotenuse is a 5. I can do Pythagorean theorem to find my missing side, but some of you might also know that 3, 4, 5 is a common right triangle. So this would be a 3, but it's pointing to the left, so we have to indicate that with a negative 3. Anytime a side length is pointing to the left, make it negative. It's really important that you get your positives and negatives correct, otherwise everything is going to get thrown off. Angle V is in quadrant 3, so draw a separate picture in quadrant 3 and label it V. And then we're given cosine, which is adjacent over hypotenuse. So the adjacent side would be negative 12. The hypotenuse is always positive, so that's 13. You can do Pythagorean theorem to get your missing side, or you might recognize 5, 12, 13 is a common right triangle. but this would not be a 5, it would be a -5 because it's pointing down. So anytime you have a side pointing to the left or a side pointing down, you need to represent that with a negative. Okay, so now we have everything we need. So we're going to follow this formula. Sine of u plus v. The formula says we're supposed to do sine u cosine v plus cosine u sine v. Now I'm going to try to color code things. So anything that's referring to a u will be red and anything that's referring to a v will be blue. Sine of u. Sine of u is opposite over hypotenuse, so that'll be 4/5. Cosine of v, here's the blue, v. Cosine is adjacent over hypotenuse, so that'll be -12/13. And remember, we are multiplying those together. And then we have plus. Okay, and I want to color code that. Okay, now we're going back to cosine of u. Cosine is adjacent over hypotenuse, so that'll be -3/5 times. And then sine of v. Sine is opposite over hypotenuse, so that'll be a -5/13. Okay, now just remember your order of operations to multiply before we add. Multiplying straight across the top, we get -48. Straight across the bottom, we get 65. Over here, multiplying across the top, we get 15, and across the bottom, 65. We have a common denominator of 65, so we can add the numerators. We would get -33. And that is your final answer. So we drew our two pictures, one for u, one for v, and be very careful about if your side's pointing left or down, should be negative, and be careful of what triangle you're looking at, u versus v. Okay, so you can use the rest of the time to work on your homework, and have a good day.